Okay, I'd like to thank everyone for attending today. This is the second in a series of talks that's part of the UNM NMSU Speaker Series. I'd like to give special thanks to Maria Lane for setting up this, Chris Duvall for hosting us, and most importantly, to Hugo Rojas Villalobos for taking the time to give a talk today. Dr. Rojas Villalobos is a professor of geoinformatics at the Autonomous University of Juarez in Cuauhtémoc. For his previous degrees, he studied computer engineering at the Tech Institute in Durango, and he earned a master's in environmental engineering from UACJ, the same institution where he works. More recently, he completed his doctoral research and studies in the interdisciplinary water science and management program at NMSU, and he was honored to graduate in the fall of 2019. He has 20 years of experience in geographic information systems. He's currently the coordinator of geoinformatics at UACJ and also serves as a member of the board of directors of water and sanitation in the municipio of Cuauhtémoc, where he lives. In his talk, Hugo is going to discuss accumulated knowledge in different areas of science as he builds a powerful tool that brings together the understanding and creativity of different tools to solve applied research problems. Geoinformatics is a discipline that brings together a wide variety of skills and knowledge that Hugo deployed to answer some interesting questions about the hydrological processes in Laguna de Bustillos. Without any more delay, I will now turn it over to Dr. Hugo Luis Rojas Villalobos, who will give his presentation. Hugo, we're all yours. You need to open up your mic.
I'm a scout. Like you, Dr. Boss. Well, thank you, Boss, for introducing me. So, everybody, good afternoon to everybody. So, I will try to be more efficient and not to be bored or boring you about this talk. But I think it's very, very interesting. What did he do when I was in the water science program at NMSU? So I will start to show you the presentation. Where is it here? Sure. Okay. And I want to show you how the power of multi-knowledge is a clue for developing things and research some topics. And this power of multi-knowledge is applied to geoinformatics issues in the Laguna de Bustillos where I work. Okay, so what is knowledge? Knowledge is everything you are learning along your life, in the time, and everything you do is a piece of this knowledge, and you are learning continuously until you're dead. So multi-knowledge is a word that you use in my dissertation, but I think I don't want to argue with the people that knows how to mix words and giving some meaning to the words. But multi-knowledge, I use it to compare two styles to learn. And in this case, I use multi-knowledge is the fact of the knowledge and skills. For example, I have a friend in my university that I call him, he's a super specialist. Why? Because he studied mechanical engineering, a master in mechanical engineering, and he got a PhD in mechanical engineering. So you can see this very straight formation. This background is very straight, only mechanical engineering. But in the other side, there are people like me that we are more for multi-specialists, not super specialists, but we know a little bit in sometimes of each area of the knowledge. For example, I studied computer system engineering. I have a master in environmental engineering, and I got a PhD in water science and management. So if you see, there's a mix of different areas of the knowledge. So when we got that knowledge and we are learning a lot of things around you, you can apply this knowledge in multidisciplinary disciplines like biomechanics and mechatronics. And can you see how these areas are connecting another areas? And you create bridges between science and other areas of the science. And the case of the MultiKnowledge construction, I started in the middle school when I studied in a technical secondary school, when with basic electronics, welding, and rules of electricity. In high school, I learned electrical mechanic, engines, wiring, and undergraduate, I'm a computer system engineer. And yes, I know it's obvious. I do programming, and in graduate school, I learned GIS, hydrology, remote sensing, and evapotranspiration. And there are a lot of skills because it's a little bit different between the knowledge and the skills. Okay, because the skills is the ability to do something. So where do I apply this kind of learning in my life and in the career in the university? Well, in geoinformatics. Yeah, maybe it's something. Yeah, it's like your area in geography, but we use more technical things like devices to get more information. And geoinformatics was born from earth science, the combination of earth science and the power of the technology. And we can see in this slide what is earth science, and and maybe you have seen these areas in geography like agronomy, minor, geology, meteorology, forestry, and these earth sciences are involved with the technology like remote sensing, drones, GIS, GPS, sensors, and prototype, and artificial intelligence. And yes, everything of this type of technology uses programming too. And let me to show you some of the this geoinformatics where you can apply this kind of skills in precision agriculture to get on time in the right place and exact amount of water, and the benefits. You can lower expenses and higher earnings. And can you see in this slide how we use the remote sensing in the agriculture, or even the drones, using this kind of sensors, and you can mix this information to get more to be more productive in the agriculture, to get better products like apples, corn, using this information. Biography is one of the areas where we apply our knowledge. For example, species distribution, conservation biology, ecology, distribution of zoonotic diseases. For example, this COVID coronavirus was born, I think, I'm not a specialist in biogeography, was born from bats, I think, when a person in China eat a bat. But I don't know if it's true, but it's one of the areas where apply our knowledge about geoinformatics. Fire detection is one of the areas where apply remote sensing, for example, developing applications in Android or smartphones or iOS to get there in the right moment, or taking the roads to get for example, this fire on the yard, and we use this information or these techniques to routing on logistics and estimation of affected areas, for example, in this satellite image. And of course, yeah, we use this information or these devices to calculate this topography and hydrological modeling, to analyze flood risk, building, urban development, and catastrophes. One of the areas where we applied, and especially applied my knowledge was in 3D water bodies, getting volume, capacity, depth, and calculating flood zones. And all this information is analyzed to get risk analysis for flood zones, damage quantification, water cycle, and need hydrological balance. Well, this is a announcement. This is my university where I work. It's a small campus in Cuauhtémoc area. Yeah, you see, it's 5 hours, 40 minutes away from New Mexico State at Las Cruces. And in this area it has some special characteristics. Why? Because this region has an overexploited aquifer. This lagoon or this lake you see in the first image is the Bustillos Lake, and it is the main water body. And this basin is in the Rake Basin. In the basin area has more than 3,000 square kilometers, where the agriculture is 1/3 of the area, and uses a lot of water because the kind of crops uses a lot of water, like corn and apple orchards. The motivation to study this area was because the limited information on the water processes, because there's no data in extension, storage capacity, and evaporation of the lake, because it's the principal water body in this place. And you can see in the images, the size of this lake is around 100 square kilometers. And you can see in the 6 images below, 6 times this lake were dried. 6 times from 2002 to 2013. And that's the reason, and took my attention to study this water body. Well, what happens if we don't have data? Well, there's no analysis. This is the main point to do my dissertation in this area. So what now, Mr. Rojas? What do you do? Well, yeah, we have to develop this the equation about this lake. First, how much does it store? Water, of course. How much does it evaporate? And the morphometric parameters, if I have only one morphometric parameters like height, volume, and area, how can I calculate the other ones? Well, and we can start here. What's the input data common for at least 2 of the 3 questions? If you figure out, maybe, is the topography. But there was one problem. I don't have any professional transducer to survey this lake. What did I need to do a bathymetric survey? I built my own autonomous surface vehicle. If you see, I use all my knowledge about electronics, programming, and water science knowledge to do this, to perform this bathymetric survey. So more than that, I have to collect more information about this region. For example, taking points of GPS, high precision GPS, take the contouring around the lake, and GIS. Well, when I got these four types of data, I forgot one of them. Extract contours of remote sensing time series. When I extract the contour using remote sensing along some years, along 7 years, to get this contour, and this contour of the water surface contour. I took this line and assigned one elevation using the bathymetry surveys or the GPS RTK surveys to get one contour. So all these images along the time when the lake was evaporating and going down the level of the water generates one individual contour. So assign one elevation, and I construct this regional DTM or a 3D model, as you see in the right in the right part. Yeah, well, yeah, I finished my 3D model. So how can I calculate the volume of the lake? Maybe you know, and you are thinking, yeah, there's one tool in ArcGIS. Yes, surface volume tool. If I get if I have the height of the level of water, I can calculate using the 3D model the volume below this line, and we can get the area and the volume. So how does surface volume tool work? Well, I previously I said that I use the height as input. The water surface is projected in a DTM pixel. The depth is calculated using the pixel size and calculate the volume below each pixel. And the output is the volume and the area. Yeah, that's right. But there's no tool to calculate the height using the volume, for example. Yeah, but if I don't have height, what can I do? Well, this is the blind box. The blind box is a concept that we use only the input data and we get data. If I input data in a process, I'm able to get information, but I don't know what's happening inside. What's the process inside? So what's happening here? What is the solution if I only have the height? Because with the height, I use the tool straightly to get storage volume and surface area. What is the solution? Iteration. We can use the same tool to get the other parameters. For example, if I use storage volume, I can get the height of the water level or the surface area. If I have the surface area, I can get I can calculate the height water level and the storage volume. How can I do this? Well, this is an example of iteration. Remember, the tool uses the height, okay, to calculate two parameters, the volume and the area. So if I put as default one height, I calculate or I can get the volume and the area. If I'm looking for a specific volume of this lake, I put this, I enter this this default height, and I calculate that volume, and I'm trying to match this information, the value of the volume I'm looking for, and the value of the volume with the default height. If this volume are equal, yeah, it's easy, you finish. But if the calculate volume is below to the volume that I'm looking for, I will increase the level of the water and recalculate. If it's still below, I need to recalculate with increasing the level of the water until I pass the volume that I'm looking for. So if I pass this level, I had to go back at the step. If I was increasing in 1 meter, I go back in the half of that distance. And this iteration is working like this. The first animation in this GIF animation. So I have to program it in Python. Another skill that I need to use to find one solution for my problem. Yeah, maybe you see this diagram. This is the iterative algorithm, and maybe it's a little bit complicated to read and how works this algorithm, but it's one of the skills I have to program and to find one solution or some solutions to one problem. So the results, it's very complex. There are a complexity in the morphometry under the water. If you see the right side, I use some. I got some areas that I calculate using the algorithm, and I build one graphic to demonstrate the relationship between the surface area, volume, average depth, and maximum depth. And you see how the surface is expanding along the average, the volume in the first meter. Why? Because the bottom of the lake is very flat and more and expands dramatically versus when the height is in 1971. That is very, very flat. So the moral of this story is never stop learning. You don't know when you will use it. Thank you.
Thanks, Hugo.
Hi, Dr. Campbell.
How are you?
I see GeoBeard.
Thank you very much, Hugo. Before I turn it over to questions, I just want to share a little insight with the graduate students that are visiting us. In this joint doctoral program we're doing with UNM and NMSU, we're looking at what we call the 3-article model for the dissertation. So the idea is that there are 3 related but different articles that will come out of the work. And in this case, Hugo has had this work published in the, one moment, while I get the name of the journal, Ingeniería y Tecnología, which is a peer-reviewed publication that's published in Mexico. So the prize that Hugo seeks to achieve in this is to get the articles published. So it was really heartening to see him develop this topic completely on his own. It comes from his experience living in Cuauhtémoc. To invent and develop the tool, he built the boat in the laboratory, deployed all of the technology that he shared with you today, gathered the data, came back, wrote the code, and got the answer. So it's a really excellent example of an applied geoinformatics approach to a question that's really important, because ultimately the data that comes out of this helps inform the water resource managers in the area that are going to do the work. So with that, I'm going to stand down and go to the gallery panel. Maria, shall we have folks put up hands for questions or use the chat? What do you think?
I think either way, maybe the chat is easier so that if anybody has internet lag issues, we can overcome those by just reading the questions.
Okay, so with that, let me get my chat window up. I invite the people in the room, so to speak, to type in questions that they may have for Hugo. And either Maria and or I will read them and then Hugo will answer them. So with that, we'll turn it over to the group to share their questions with everyone else.
Yeah, thank you, Dr. Brown. It was very challenging this research, because when I was doing my qualifying exam, I remember you asked me, you, Dr. Brown and Samani and Blair Stringham, you can finish this in this while you be here in 4 years. And I'm very confident. I was very confident in that moment, but when I was advancing along in the time and getting more information, I saw that it was very challenging, because not everything is in your way. I had to go apart to get information, to get resources, and to fund this project using funds from WURI, the WURI project. You remember? Yeah.
So it's very exceptional work to have Hugo have mastered these technical tools, invented a couple of them, and used them to answer a very, very important applied research question. So the first question that we have from Carol Campbell, I want to discuss the modeling approaches you employed.
Yeah, sure.
Hugo, could you possibly put up the relevant slide?
Yeah.
And walk us through it one more time?
Okay, let me.
Can I talk with him?
Of course.
See?
You're my boss.
Oh.
I'll stand down.
Yes, so Hugo, I remember your work in the Spark Lab, and I'm teaching landscape ecology this semester, and right now we're talking about models. And so
Yeah.
I mentioned to the students how I remember you, building your boat,
Mm-hmm.
and how we joked about, I thought you were, working here, but you're building a model boat, and I thought that was really innovative of you to design this autonomous tool to calculate that bathymetry. And so I'm glad to see the graphics that you have in your presentation here to show how you have to go through all these steps, and sometimes you don't, it's not as easy as it looks on the graphic, right?
Yeah.
There you go. You get some field. Yeah, there's the boat. Yes.
Yes. When I was building this, after build this boat, I used it to track the paths in the surveying paths in the right, in the right image. And my prototype in the last path hit the bottom of the lake, and one of the how is it called, propels went out, and the boat started to do circles. Yeah, in circles. So I had to put one stake sticking in this pipe where the propels where is like the transmission, and I continue to finish one segment of this bathymetric survey by hand. It was very interesting.
Yes, so sometimes the equipment you need does not yet exist, and so very
Exactly.
innovative to create your own equipment.
Yeah, exactly. In this case, I was looking for one autonomous boat, but the cost in Mexico is it's like a skyrocket, right? $30,000. So well, yeah, it's I have to build one. So was that was the main reason to construct this model?
Excellent, good. Thank you.
Okay,
You're
our
welcome.
next question is from Dr. Duga. You see differing levels of complexity for the bottom topography. It's very interesting in terms of understanding geomorphologic evolution. Do you think your tool can assist geomorphologists?
Yeah. Yeah, we can understand the evolution of this lake first. How the runoff is working when the runoff is getting into this lake, and how the sedimentation is spreading into the lake and the bottom of the lake. It's very important because this lake is very flat of the bottom, and so the average the average of the depth in this lake is maybe from 1.5 to 2.5 meters depth. In some parts of the lake, I remember when I was getting some information in the lake, I walked into the lake, maybe 500 meters, and the depth was maybe 60 centimeters. So it's very, very, very shallow lake. And with these models, yeah, you can see how is this geomorphology underwater is located. For example, in this image, you see this like an island, but when the lake is dry, the air from the east, from the west, pass from over this part and get the pollution of this dirt, this dust to the right side. And in one of the if you see the model here, Dr. Duga, if you see the
Yes.
right side of the
Yes.
lake is very shallow. Is shallower than the left side, maybe for 40 centimeters. But this is produced because the sand of the left side of this island is going to the right side due to the wind. And yeah, you can see the complexity under the water.
The next question is from Roald Kern, which builds nicely on Dan Dugas' question. Has there been a noticeable change in the shape, topography of the lake bottom when it would dry, fill, and dry again? So can you speak to the change in bathymetry as we see wetter and drier periods?
Oh, okay. Yeah, in the bottom of the lake, it can change a lot. we can detect some changes, but it's very, very, very important to know that it's very flat. So the differences can be maybe for 3 centimeters, and everything changes. Yeah. When the lake dries, the dust, the wind get this sand and get this sand to the other side. So, but this process is very, very slow to get this this part of the sand to get rid of this part. So it's noticeable, but I think we have to do more more surveys first. And I have one core of sediments, and I dated these sediments here in Mexico. So we can do something else in the lake to see these changes along the time.
Thank you. The next question is from Chris Duvall. Do people who live around the lake use the surface water significantly, or is the main management issue dealing with aquifer use?
This lake has a big problem. It's polluted. There's one paper mill. It's a paper mill?
Paper mill.
Yeah, there's paper mill next to this lake, and this industry is there since I think 1970s, and they pour their products, the final products, into the lake. So it's very polluted. Heavy metals and all the agricultural industry, fertilizers and some plaguicides. How it's called, plaguicides? Is there the water leaches this fertilizers and went to the lake, and it's very salty. So the people don't use this water, but some of people that lives in the north part go fishing to sell these fishes, but they are contaminated by heavy metals and fertilizers.
So I'm going to merge the next two questions together because it's about building the boat. So Emiliano Salazar wants to tell us a little bit about the sensors, communication, GPS collection, and navigation. And Ruben asked you how long it took to build the boat. So if you can tell us how long it took to build it, and then how you put things together, and the question about sensors, communication, GPS, and navigation.
Well, how long took me to build this boat? Maybe 6 months, I think, because yeah, you know, some parts. For example, the hull. I have to I did that model with foam, and I give to another person to do the form, the
fiberglass.
The fiberglass, yes, work. So for another, in the other hand, yes, I program. I program in C, in Python, in Net, and in some languages. But in Arduino, using the next questions. I had to use Arduino prototypes, and I had to program these boards in Arduino in C. So I had to learn how to use these proto boards and connect and to how to decode the bus data from the GPS, the transducer, at the same time to save this information in a memory in the Arduino chills. The navigation I bought a device called ArduPilot. The ArduPilot is a specialized board of Arduino that takes the GPS and send information to the propels to put more power in one of the propellers to turn to the left, for example, or to the right, the boat. So I use Arduino to integrate the sensors, communications, GPS data collections, yeah, and another Arduino device to navigate using C, programming in C.
Thank you, Hugo. The next question is quite different. Daniel Bean wants to know about multi-knowledge. So he asks a question about co-producing knowledge as part of a team. Can you speak about the process of finding specialties, communicating a common goal, and then knowing when you actually produce knowledge that's the sum of all the inputs? So he's very interested, as I was, in this idea of multi-knowledge and how you pulled those pieces together.
Yeah, very, very interesting. And for me, I'm still thinking about this because I'm very lucky to study all this stuff and get all this knowledge to put it in the to use it as solution to problems, right? So I think when we know how what we do, and it's like I talk with my students. This is like the Lego blocks. Yeah, we have different type of Legos. So one block or not Legos, blocks. 3, 4 small ones, wheels and tires, and with the concept of knowledge, you have all these Legos in your table, and you need to be very conscious what you know. If you learn something in the past, maybe you can use it right now. For example, well, yeah, this is maybe for the younger people when they are using video games. Video games train your hands to be more delicate. No, it's
Coordinated.
what? Coordinated.
Oh, coordinated.
Yeah, your brain and your hands are coordinated. And even if you are seeing something, you are able to detect something very fast. One of my younger son, Ricardo, my son, he played with the GameCube, I remember, on the bed with but lie in the bed, seeing the television rotated, playing in that game board, right? So it's very interesting how your brain is coordinated with your hands, and for this answer question, can you speak about the process of finding specialties, communicating a common goal? In this moment, I'm able to be in a team, maybe with a super specialist in GIS more than me, maybe with some people that knows electronics more than me, but they don't know what the GIS people is doing. But when you know both areas, you can you are able to communicate between them and coordinate work teams. And I think this is the point where you are constructing, producing knowledge. Using this inputs.
I was very impressed with that concept you started with. When Hugo worked on this, the big focus at the beginning was the boat. Building the boat, figuring out how to get the boat work, get all the technology. But as he made this presentation, I was very impressed with this idea of common knowledge and the super specialist mechanical engineer and the multi-specialist Hugo. I found that to be very interesting. The next question is, thank you for sharing your knowledge and expertise. Can you talk about community involvement? Some of the places would harbor knowledge, such as a body of water, that's important to local people. Camilo also thought that the boat was cool too, as did I. So can you talk about how your work related to the community, and perhaps that video clip that you did might be helpful to talk about?
Yeah, it was very impressive. Yeah, the involvement of the community when I was doing that survey. When I had this boat, I had to take to Cuauhtemoc because the boat was built in Las Cruces, right? So I took the boat and got it into Cuauhtemoc area, and I went. I needed to have one area where I put the truck, my equipment, and the boat. And I went. I was looking for somebody to help us to do this survey, and I went to the how it's called, the authorities of the municipality, and they provide some help, but not enough. They don't care. They didn't care about the research. But one of the people around the meeting with these people with the authorities told me there's one people that have one area, one plot next to the lake. And I went, he's Luis, Mr. Luis. Mr. Luis, I'm coming from UHCJ, the university next to Cuauhtemoc. Nice to meet you. And what do you want to do here? I need to get the depth of the lake. Okay. You need my boat? And when you talk with these people, with the people that lives from this lake, they involve easily. I come to help you to find the deeper areas, the deepest area, and how the deep is along or in the lake. He told me, only I ask you one something, give me a map. Give me a map, where am I? Where I am, and where is my plot? Where is my area next to the lake? And these people, they were very helpful to finish this project, because when the boat were surveying and came and hit the bottom of the lake, and the axle of the propel went out, he offered me to take me to finish this this survey using a cord in the boat, and he was driving his boat by hand. And it was very interesting how the people involves in how the community involves in the project. If they think is helpful for them, they will apport something in species.
Your timing is perfect. That was the last question that we had.
Mm-hmm.
It's now 4 o'clock. I would like to thank Hugo again for participating. The only thing that's very sad about today is that because of the pandemic, we're in Zoom.
Is your class over?
So we can't walk across the street and have a drink and a dinner. So we'll have to have me go down and visit with Hugo to bring him our thanks and our good wishes to him. So with that, I'd like to thank Maria, Lane, and Chris Duvall for helping organize all of the UNM participants. We have more people in this Zoom room than we get in the room in the building when we give the talk. So it's really, really great. With that, if anyone has any last minute comments, questions, or concerns, I invite you to share them with the group. And if not, I'll turn the room back over to Maria, and I will turn the host back over to Maria so that you can run your meeting. So one moment, please, while I do that.
I'll just say thanks everyone for coming. Thanks, Hugo. I'm glad that we're able to work out this joint speaker series. It's really great to have all of us together.
Yeah, thank you.
Okay, abrazos, Hugo.
Abrazos.
Muchísimas gracias.
See you.
Okay, thank you, everyone. I'm stepping off. Hugo, be well. Take good care of your family. We'll see you soon.
Yeah, I have another meeting.
Okay.